Because the Council for Scientific and Industrial Research has made a presentation on changing southern oceans to Countdown 2023 TEDx Johannesburg. Research highlighted the implications of high iron stress levels on microscopic marine plants and its effects on global oceans. Senior researcher Dr. Tommy Ryan-Keogh joins us now for more on that. Good to have you, and thank you very much for your time. How quickly are the oceans changing, and is it a change that can be visibly seen immediately, or is it something that would still take time for us to even begin to recognize?
Yeah, thank you for having me on. That's an interesting question. So the study that we published has looked at the last 30 years, and it has been a subtle change. The problem is we don't really have a lot of data that exists prior to the 90s, when we started to develop the appropriate sensors to measure the right things to understand if climate change has been affecting our oceans. So it could very well be that these changes started much earlier than what our study has published, but the changes we are seeing are quite significant.
Are these changes, or in fact your discoveries, inspiring significant dialogue around the seriousness of climate change?
Yes, there's definitely getting a dialogue going amongst Earth climate scientists, particularly because the models that we use for future climate projections were actually predicting the opposite of what we've found in the Southern Ocean. So it's raising questions about whether or not we are actually getting completely true, accurate pictures of what the planet Earth will look like by the end of the century.
Yeah. So talk to us then about these microscopic marine plants and their relationship with iron, and how this is now changing the ecosystem of our oceans.
Yeah, these marine microscopic plants known as phytoplankton, they need this micronutrient iron in order to photosynthesize efficiently. So if they're not photosynthesizing efficiently, they're not absorbing as much CO2, and they're not being as productive. Now, this can have two major impacts which should concern us all. The first is that they form the base of the marine food chain. So without phytoplankton growing as much, you're not going to be able to sustain the larger animals at the top of the food chain in the Southern Ocean, such as whales and seals and penguins. The second is that they play such a hugely important role at absorbing CO2 that is dissolved from the atmosphere into the oceans. This carbon becomes trapped at the bottom of the ocean when they die and lives there for thousands of years. Now, if they're not photosynthesizing as much, it means we could end up with more CO2 remaining in our atmosphere, further amplifying the negative impacts of climate change.
So, one, we are likely going to see a decrease, I suppose, in the general population of our sea life.
Yeah, you could very well see some very huge negative impacts on the whole food chain, which is going to have a huge knock-on effect for the blue economy for any countries here that are in close proximity to the Southern Oceans, such as South Africa. And
how does that then also, I suppose, affect the productivity levels and our ability to maintain this ecosystem?
Without phytoplankton forming this base of the marine food chain, you're just going to see declines in the fish stocks, and you're going to see potentially an ecosystem shift away from phytoplankton being at the bottom. There could be other animals that move in to take over these niches in the ecological system, but we really don't want to disrupt the system that much.
I suppose, more specifically, I'm asking as far as the fishing companies are concerned. I mean, are we likely going to see their productivity levels being affected and thereby affecting the economy, affecting jobs, and so on and so forth?
You could begin to see those downstream negative impacts within the next few decades, certainly.
And is this something that we can do now? And even if we do it now, I'm not sure whether it will reverse the process completely, or at least it will prevent it from continuing further.
Yep, the most simplest way to combat this is just to begin lowering our carbon emissions. If we begin to lower our carbon emissions, then at least we give the natural ecosystem a chance to correct and fix itself. If we do not do this, then the chances are we could cross many different tipping points where it will no longer be able to reverse the damage we have already done.
And how is this particular information going to be used? I mean, you have now made this groundbreaking discovery, particularly making scientists excited. But how is it going to be used?
So we are going to use the learning from this study and future studies we are planning to try and improve the Earth system model that we are developing here in South Africa within the CSIR. It will be one of the first Earth system models that has actually been generated by the African continent. And we really want to make our niche in this science space specific about parameterizing the Southern Ocean and its role the most effectively compared to all other Earth system models out there.
Yeah. It would be interesting for me just to get a sense from how did you do that? I mean, very, very earlier on in my life, I don't think I can do it now, but I was an open water diver, so I did go down quite down underneath there. It's serene, it's quiet, and it is beautiful to watch. But how did you actually do this particular style? I mean, were you telling in a number of dives going down there to have a look?
Unfortunately, I only dive recreationally, so my main job is that I go out on research ships to the Southern Ocean where we collect samples that we either measure with instruments on board the ship or we bring back to land. This particular study, we developed an algorithm that we applied to some marine robotic platforms that we deployed in the Southern Ocean. But as great as these studies were, we really wanted to get an understanding of long-term change. So it was quite how do I say this? We were quite lucky that the algorithm we had developed could be applied to any data that had been collected in the same way. So I began searching through all historical records to see how much data I could find that would meet this criteria and apply the algorithm to it. So I managed to repurpose existing data to tell us a really important story.
Yeah. Would you say this is partly also part of the example of what they call Fourth Industrial Revolution and the use of robotics in helping us exactly understand the world around us?
Yes, and it's also in huge part to the CSIR's Center for High Performance Computing. I would not have been able to conduct this study without all of the industrial investment that had been put into developing this excellent capacity for South Africa.
Yeah. One of the other important things that I see you're noting here is that it's of course a broader call for all of us as society, reduce our carbon emissions, certainly do our best to protect the ecosystem. But there is some kind of action that could be taken at a policy level. Scientists are doing their bit, but policymakers need to play their role. What is a significant thing that they can do as policymakers?
I would put massive investment in renewable energy. Not only could you start to guarantee energy security for South Africans, but you could begin to lower youth unemployment if you set up these massive training schemes. They could become the next generation of engineers that install wind and solar energy across the country, which will create economic upliftment for all South Africans.
Dr. Wright, appreciate your time. Ryan-Keogh and Dr. Tommy Ryan-Keogh, he's a scientist with the CSIR there, having conducted this particular research. I appreciate your time. Thank you very much for bringing that intervention to